Welcome back, so to say. On the back side of that prior paper that you just finished, this time we're going to work backwards again. I gave you a graph. I didn't label everything completely, so we're going to talk about that. And from there, we're going to use the information from the graph to create a table. First thing I would like to do is we need to label our X and our Y. Remember again, X is the horizontal, the Y is your vertical. X is your independent. That's the thing we cannot control. In a table, in this situation, we can't control time. An hour will always be an hour. So this will be the time. Again, our unit will be hours. Not sure what I was going to write there, but here we go. Hour. Sorry, couldn't even see. On the Y, that will be our distance in miles. So I'll just write distant. And then I'm going to label miles as opposed to kilometers or yards or feet. We got to give them that information. I know we're going to be doing some counting, so we have to also determine what was the interval, meaning what did I decide to count by? Talk with your neighbor. What did I do? What did I count by here? And then I want to know the interval for the Y's. Take a moment, talk with your neighbor, determine what did I count by. Here I went 0, skipped to 1, skipped to 2. So I counted by half, or you can say 0.5. Either is okay with me, meaning if I had to fill in the gaps for the lines I didn't label, I would count by a half. Then from here, I counted by fives. My interval was fives. So if I had to fill in the blanks, even though I think it gets a little crowded, you definitely may do that. Okay, we're going to connect the points. We need to figure out how fast was this person traveling. We will connect this ordered pair to this ordered pair. What I know is I can't say, oh, in 3 miles they went, or in 3 hours they went 50 miles, because they didn't start at 0. Remember, we talked about non-proportional relationships. This person did not start at home or at school or at the bank. They started 20 miles from somewhere and continue to travel away. So we have to figure out what was their distance per hour. That's what we need to know. Well, our interval is a 5, so I have to count by 5s. How many rows tall is this? So 5, 10, 15, 20, 25, 30. So they were able to go 30 miles. And we counted by half. So a half, 1, 1.5, 2, 2.5, 3. In 3 hours. That means that this person or this object traveled 10 miles per hour. That is their unit rate, their constant rate of change. We could also do some just thinking by looking at the graph. If we start here at 20 and this person went to 50, so from 20 to 50, that is a change of 30. From here, we went from time 0, the starting, to 3. That is also a 3. That's another way we can do it. Let's just verify with this one. I'm going to just do things different to show it can be done both ways and draw my right triangle above the line. It won't make one bit of difference. I'm just darkening it so that you can see it. But I'm connecting that ordered pair to this ordered pair. Okay, a couple ways we can do it. Let's just think about it first and then we will count. We have to figure the change in the distance over the change in the time. So this person started here at 50 and up at this point, they had traveled to 90. So 50 to 90 is how many miles? 40. But another way to calculate 40 is just count the rows by the interval. So 5, 10, 15, 20, 25, 30, 35, 40. Absolutely. So this person went 40 miles. Now we got to figure out how long it took them. We can look here. We can see that this starts at 3 and ends at 7. So from 3 hours to 7 hours, that's a total of a 4-hour journey. But we can also count the rows following the given interval of a half. So a half, 1, 1.5, 2, 2.5, 3, 3.5, 4. So I have 4 hours. When I simplify, I get 10 miles per hour. Excellent. Okay. Now that we know the person is traveling 10 miles in 1 hour, we can use that information to fill in our table. Something we need to remember, this person didn't start at home, didn't start at school. He started or she started right here, 20 miles from wherever, the store, a friend's house, school. So at time 0, they are not here at the starting point. They are already 20 miles away. So make sure at 0, you have the person starting 20 miles away. We know that the person now will travel 10 miles in an hour. So if I want to extend my table, 1 would go right there. So that would be in 1 hour. I would need to add 10. So now they would be 30 miles from their starting from the corner, wherever. To get to 2 hours, I could add 1 more, and then I would add another 10 on this side. They are now 40 miles from where the corner is. They have traveled 20 miles so far. So after being in the car, in the road, going for a walk, traveling, we could add the missing numbers if you would like. After another hour, they would be at 50, another hour at 60. After 5 hours, they would be at 70. So let's just take a look at our graph. After hour 5, that's right here. If I look to the left, there they are at 70. Excellent. Well, if in 1 hour they can do 10, this is a 3-hour jump. What would I add to my 70 so that I could figure out where that person is on the 8th hour without extending and filling in all the gaps for 6, 7? I would add 30. For every 1 hour of change, they add 10 miles. So this person would be 100 miles. So if I carefully look at my graph, if I did a great job graphing, I did an okay job graphing, probably should have used a better ruler. But if I look it did fall at 100. If you need to, so that you can get all this information down, please pause the video again,